Hey guys, welcome back. AMC 10B 2022, problem 8. I'm not gonna lie, I got stuck on this one for a little bit. This one caught me off guard. I knew there was a pattern, I knew there was a strategy. I was just getting really stuck on how to find the pattern. One thing I knew is okay, consider the following 100 sets of 10 elements each 1, 2, 3 to 10, 11, 12, 13, 20, 21, 22, 23 up to 30, and then et cetera, all the way up to 1,000. How many of these sets contain exactly two multiples of 7? Well, to contain exactly two multiples of 7, any two multiples of 7 are always going to be 7 apart from each other, obviously, because it's like 7 plus 7 plus 7 plus 7. That's how you make a multiple of 7. So they have to be a distance of 7 apart. The only way that that's possible is if the first multiple of 7 is within the first 3 numbers in the list. So the first multiple of 7 has to be within the first 3 of each set, right? So I was kind of running through and thinking to myself, well, what multiples of 7 end in a 1, a 2, or a 3, right? Well, first you come across 21, right? Then you keep going, and then you're going to get to 42. And then the next one you're going to get is 63, right? So you're going to hit 21, you're going to hit 42, and you're going to hit 63, all within the first 70 numbers. And then notice once you hit 70, it's kind of like resetting because now it's like starting at like 0 again, right? Because 70 is a multiple of 7, and it's kind of like you can count it as being like 0, right? And then the next would be 77, which corresponds to 7, and then 84, which corresponds to 14. So we can look at them as sets of 70, right? And if we think about it, we're going to have every set of 70 sets, every group of 70 sets, we will have 3 sets with a multiple of 7 within the first 3 digits, which means it will contain exactly 2 multiples of 7. So every group of 70 will have 3. 1,000 divided by 70 is 14 with a remainder of 20. So we're going to 14 sets, right, which would have 3 in each set. So 14 times 3 is 42. Now we have to ask ourselves, could there be one more in those extra 20 left over at the end? Because 14 times 70 is 980. Well, we can think 980 is a multiple of 7, right? 987, no, because, right, that doesn't end in a 1, 2, or a 3. 994, no, doesn't end in a 1, 2, or 3. And the next one's over 1,000. So therefore, we would have exactly 42 sets that contain 2 multiples of 7. So therefore, our answer must be B, 42. So yeah, this is a tricky one. I'm very interested to see if anybody came up with an interesting method to solve this. All right, I'll see you for number 9.